Good morning students, welcome to our next lecture of data structures and algorithms. Our today's topic is trees. Till now we have studied about the linear data structures and non-linear data structures. And in non-linear data structures we have two types of data structures, trees and graphs. So today we will study about the introduction of trees. Trees are non-linear data structures. Non-linear data structures means those kind of data structures in which data is not stored in a proper sequence or in a proper format. That proper sequence can be described as the sequence of arranging data either in increasing form or in decreasing form. Okay, so linear means data in proper sequence, and in non-linear means data which is not in proper sequence. Understood? So this was the basic difference between linear data structure and non-linear data structure. So in non-linear data structure we arrange or we store our data in memory, not in a fixed form. So for arranging non-linear data structure we are using trees. Trees is such a kind of data structure in which we will arrange our non-linear data in memory. So trees are non-linear data structure in which data elements are arranged in a sorted sequence. Sorted sequence means, here sorted sequence is written. Sorted sequence means the non-linear data that we have, and we want to arrange that non-linear data into our memory. What we will do, we will sort that non-linear data into a sequence, into a sorted sequence, and then we will store that non-linear data into memory. Okay, so trees are non-linear data structures in which data elements are stored in a sorted sequence. Now let's discuss the definition of tree. A tree can be defined as a finite set of one or more nodes. How we can define a tree? A tree can be defined as a finite set of one or more nodes. Okay, a tree contains a set of one or more finite nodes. One or more finite nodes means a tree can contain either one node or more than one node, but those nodes should be finite. Finite means a fixed number of nodes, not the nodes that we don't know the number. So a tree contains a finite set of one or more nodes, such that now since we are having a finite number of nodes in our tree, but how we can define those nodes, how we can classify or connect those nodes with each other. So we will study that those finite set of one or more nodes are available, are present in the tree, such that the conditions of those finite set of nodes are, there is a specially designed node called the root. Now from the finite set of nodes that we have in our tree, there is only one specially designed node, and that specially designed node is known as the root node of our tree. So the only one node that is present in our tree from finite set of nodes, that specially designed node is called the root node of our tree. Here we are having an example of tree or we can say that a simple tree diagram. In this tree diagram we are having a finite set of nodes. These A, B, C, D, the alphabets written in circle represent the nodes, and these lines which are connecting these different nodes to each other are known as the edges. Okay, so the thing that we just discussed about the specially designed node called the root node, so this topmost node that is present in our tree is known as the root node. We are calling this a specially designed node, or we are calling this root node because all other nodes are children of this root node. Okay, so in a tree we will only have one root node, and that root node will be connected to other children of the tree. Other nodes will act as the children or sub children of the root node. So this A is the specially designed node, and that specially designed node is known as the root node of our tree. Okay, I hope you have understood the first point. Now we will discuss the second point. The remaining nodes are partitioned into number of disjoint set T1, T2 up to Tn. Now the other nodes that are present other than the root node, here root node is A, other than the root node A we are having nodes B, C, D, E, F, G, H, I, J, K and L, okay, and M. These other nodes other than the root node, these nodes are partitioned into disjoint sets. What we will do, we will partition these other nodes means the nodes which remain after the root node. So these other nodes will be partitioned into disjoint sets, and those disjoint sets will be named as T1, T2 up to Tn. Here T, capital T represents the tree. Okay, so these other remaining nodes other than the root node will be partitioned into number of disjoint sets T1, T2 up to Tn, where each of these sets is a tree T1, T2 up to Tn. Now after partitioning the other nodes into disjoint sets, what we will do, each of these sets means, now let's consider this node B. B is considered as a tree T1, C is considered as another disjoint set T2, D is considered as another disjoint set T3. Okay, so where each of these sets is a tree. Now these disjoint sets will then represent themselves as trees, okay, as trees, and on considering B as a tree T1, E, F are B's children, and K and L are sub children of E and F. Similarly, we will consider C as another tree and G as its children, D another tree T3, and H, I, J are its children, and M is its sub child. So in this way we can partition the remaining nodes, the nodes remained after the root node of the tree. We can partition the remaining nodes into disjoint sets, and these disjoint sets will be represented as trees or subtrees of the root. So this is the root, and these will be represented as the subtrees of our original tree. Okay, now here I have written the levels, level 0, level 1, level 2 and level 3. But before that we see here this is an example of our tree. In this example, we are having number of nodes, finite set of nodes and edges. So the number of nodes, the finite set of nodes present in our tree are connected to other nodes through the edges, and these edges are connecting one node to another node. And the last child that we are having in our tree, last child means that no further children of that node are available. We call that node as leaf node. Here K, let's consider K as node. Since no further children are available of K, so we call K as leaf node. Similarly, L is also a leaf node because no single child is available. G, H, M and J, these are all leaf nodes because they don't have any children or child or any subtrees. So we call these nodes as leaf node. Now let's talk about the level. Level here denotes the finite set of nodes arranged at a proper level. Always keep this thing in mind, the root node will always be present at level 0. We will always denote root node at level 0. Root node is our topmost node of our tree. So root node will always be represented at level 0, and all other nodes will be represented lower than below the root node. So here root node is present at level 0. After considering the root node, we are having 3 children of root node B, C and D. These 3 children are present at same level. So we will name this level as level 1. After considering these children of root node, we will consider the next subtrees of these children into another level, and further subtrees, subchildren are available. We will classify them according to their levels. So levels represent the depth of the tree. Depth of the tree means how deep our tree is. How deep our tree means how many levels, how many subtrees, children, subchildren are available in our tree, starting from the root node to the leaf node. These are represented using the levels. Okay, so now we have discussed about the root node, about the edge, leaf node, levels. Now for solving further problems of trees, we will encounter some terminologies. Those terminologies can be path. First one is path. Second one is degree of a node. Degree of a node. Degree of a node. Degree of a tree. Branch. Branch. Non-terminal node. Non-terminal node. Depth. These terminology will be frequently used These are the terminologies that we will be frequently using in our tree data structure. So let's discuss about these. First one is path. Path is nothing but a way of traveling from one node to another. One node to another means from source node to destination node. So for traveling from source node to destination node, we follow a particular path. We follow a particular way, and that way is known as the path of the tree. So here let's take an example. If we want to reach from A to M, if we want to reach A to M, we have the path. We will go to node D through this H. After D, if we go to H, we will not reach towards the M, that is our destination node. So we will skip this way. Then after reaching D, we will check for another way from D to J. If we go from D to J, we will again not able to reach to M. So we will also skip this path. Then we will check this path. From D to, we will move from D to I, and from D to I we will reach at I. After I, we will see the path and we will reach to M. So from A is our source node, from where we want to start our journey, and M is our destination node to which we have to reach. So the path that we will follow will be A to D, then D to I, and I to M. So this is known as the path of the tree. Next terminology is degree of a node. Degree of a node means how many children does a node have. Degree of a node means how many subtrees or how many children a node have denotes the degree of the tree. So here if we want to calculate the degree of node A, then the degree of node A can be calculated as the number of subtrees of node A. So node A have only 3 subtrees, B, C and D. So degree of node A will be 3. On considering the now let's take another example, B. We want to know the degree of node B. So for calculating the degree of node B, what we will do, we will see the number of subtree of node B. This is our node B. We will see the number of subtrees. Node B has only 2 subtrees, E and F. So degree of node B will be 2. So degree of a node means the number of subtrees a node contains is known as the degree of the node. Third terminology is degree of a tree. Degree of a tree means any tree, degree of a tree is the maximum degree of the nodes in the tree. Maximum degree of the nodes in the tree. Maximum degree of the nodes means any node which contains the maximum degree will give us the value of degree of a tree. Okay, try to understand. Degree of a tree. Degree of a tree means the maximum degree of a node, the maximum subtree of a node. So on checking this example, here we are having A as root node. Now let's calculate the degree of this whole tree. So for calculating the degree of this whole tree, what we will see? We will see the degree of each node. On considering A as node, we will calculate its degree will be B, C, D. 3 subtrees are available. So degree of A is 3, degree of B is 2, degree of C is 1, degree of D is 3. Degree of D is 3 because we are having 3 subtrees of node D. Now degree of E as 1 because we are having only one subtree. Degree of F is 1, degree of G is 0, H is 0, I is 1, J is 0 and M is 0. So we are having maximum degree available as 3 of root node A and root node D and node D. So the maximum degree that we are getting according to this given tree is 3. So this tree, the degree of this whole tree will be 3 because the maximum subtrees of a node are available only 3. So this will give us the degree of the tree. Next terminology is branch. Branch, as we already know, branch means the children of the same parent, that means A, we are having A as root node. A has 3 children, B, C and D. So we can say that A has 3 branches, B, C and D. So this is the meaning of branch. A is having 3 branches, B, C and D. On considering B, B has only 2 branches, E and F. C has only 1 branch, G, and D has only 3 branches, H, I and J. So this is the meaning of branch with respect to this given tree. Next terminology is non-terminal node. Non-terminal node. What is the meaning of non-terminal node? Any node whose degree is not 0 is known as non-terminal node. Okay, any node whose degree is not 0. Here we are having degree of node G, H, J and M as 0. So G, H, J and M are not non-terminal nodes, they are terminal nodes. Terminal nodes means no further subtrees or subchildren are available. So a non-terminal node is a node whose degree is not 0. Okay, always keep this thing in mind. Non-terminal node is a node whose degree is not 0. Its degree should be greater than 0. It can be 1, 2, 3 or any other, but a node should contain a degree. A node with degree 0 will not be a non-terminal node. It will become a terminal node because no further children or subtrees are available. Now the last terminology that we will discuss